Gaurav sir is talking. Okay,
Yes,
sir,
yes.
Gaurav sir, we have not officially. We will start. Just a minute.
Okay,
I am
okay,
telling
okay.
organizer to put the screen.
Okay, okay, okay.
Visalini,
Yes, ma'am.
kindly put the screen of the poster first.
Yes, ma'am.
Poster screen.
Poster screen, ma'am.
And sir will start now.
Yes, you can go ahead, ma'am.
Shall I start, ma'am?
Start, Visalini.
Yes, ma'am. One second. Wisdom's instruction is to fear the Lord, and humility comes before honor. An intelligent heart acquires knowledge, and the ears of the voice seeks knowledge. The one who gets wisdom loves life. The one who cherishes understanding will soon prosper. With these words of knowledge and wisdom, I of Department of ISC welcome you all to this auspicious event. Now I request Principal and Chief Guest to inaugurate the session. One second. One second, sir. One second. Now I request Principal and Chief Guest to inaugurate the session. Sir, please inaugurate button you have to click. Sir, in screen inaugurate button is there, no sir?
Not able to do, ma'am.
Not able to do, sir?
You can do it, no problem.
Yes, sir. I now call upon Ms. Manjula, Assistant Professor, Department of CSE, to present a welcome address. Manjula, ma'am.
A very good morning. Very good morning to one and all. Ma'am, am I audible?
Yes, ma'am. Yes, ma'am.
Yes,
A very
yes.
good morning to one and all. On behalf of the President of Children's Education Society and Chairman of the Oxford Educational Institutions, Management, Principal, Deans, HODs, staff, and students of the Oxford College of Engineering, I, Manjula, Assistant Professor, extend to you all a warm welcome to the 2 weeks Faculty Development Program on Advancement in Quantum Computing and Sensor Technology for Viksit Bharat at 2047, organized by the Departments of Computer Science and Engineering, Information Science and Engineering, Electronics and Communications and Engineering, and Electricals and Electronics and Engineering. It is indeed an honor to have you all gathered here today to explore the exciting world of quantum computing and sensor technology. We would like to start the event in the remembrance of our respected founder, Chairman late Shri S. Narsaraju Garu, the founder of Children's Education Society. We remember him forever and his blessings are there upon us on all our endeavors. On this occasion, we would like to welcome our Honorable Chairman, Dr. S.N.V.L. Narasimharaju Garu, to this event in his absence. The inspiration behind all the activities in our organization is our principal, Sir Dr. N. Kannan, who is an active researcher, a motivator, and a great administrator. We welcome you, sir. It's my great privilege to welcome our IEEE branch counselor and Dean of Research and Development, Dr. Preeta Sharan ma'am to the event. I would like to welcome our respected Dean Academics, Dr. Vijay Kumari ma'am, Dr. E. Sarvanakumar sir, Head of CSE Department, Dr. Kanagavali ma'am, Head of ISE Department, Dr. Manjudevi ma'am, Head of EZ Department, Dr. B. Devi Vigneshwari ma'am, Head of EEE Department to the event. I would like to welcome Head of all the departments, staff, and students to the event. With a great excitement, once again, I welcome all the external and internal participants to the 2 weeks FDP. I wish you all a productive, insightful, and a rewarding experience throughout the duration of this FDP.
Thank you, ma'am. Thank you, Manjula, ma'am.
Welcome.
Now I request our principal to address the audience.
The most respected Dr. Gaurav Kumar Bharti from IIIT Bhopal and the professor from Peru University and our Dr. Preeta Sharan, IEEE branch counselor and Dean R&D and other deans, heads of the departments and our faculty members and the external participants. Good morning to all of you. So today we are inaugurating the 2 weeks FDP program on advancement in quantum computing and sensor technology. That is for Viksit Bharat at 2047. That is, Viksit Bharat is nothing but the government roadmap for making India to equip in all the level. That is by 2047. That is after the independence of 100 years of after the independence. So in order to, the government of India is taking a lot of initiatives on the latest developments and technologies. So we have to be on par with that is other countries. So based on that, the quantum computing has chosen because the April 14th is celebrated as a quantum day for in the worldwide right from 2022. So in order to that is make awareness among each and every one of that is the educators, scientists, and the students. That is the quantum computing is nothing but it is a multidisciplinary. That is, it comprises of computer science, physics, and mathematics that uses the quantum mechanism. That is almost it replaces everything. That is, instead of going for AI and other things, if you make use of the quantum, you can do it in that is maximum process within very limited time. We no need to spend a lot of time on this instead of using the bits, ones and zeros. If we use the qubits, we can that is complete the task very soon. That is in terms of seconds we can complete. So in order to make awareness, as well as a lot of researches are going on in this field. That is, eminent professors working in across the world, across our country, are going to take the session for this 2 weeks FDP. That is even from the outside country of India. Many people are taking the subject, that is seminars on the quantum computing based on the research what they have done. So definitely it is a eye-opening session for all the freshers and those who are doing the research in this field. Even those who want to aspiring to have research on this field, so they will get some knowledge about this. Definitely the next 2 weeks is going to be a very good session for all of us. It inspires each and every one of you to that is go into this field. So definitely you will involve yourself and you will choose some field based on your that is interest, so that a lot of research activities will take place in India. So we will also be in part with that is the other countries. That is nowadays the United States of America is doing a lot of research on this quantum computing. They are leading the world. So we are also, we have to go along with hand in hand with other countries. So it is one way of making the faculties to enrich on this quantum computing, and based on this, they will propagate this among the students and research scholars and everybody. So that that is our vision of our Viksit Bharat, that is in the year 2047. So definitely, as a citizen of India, every one of us will fulfill that. And for this, the IEEE Bangalore section is helping us to conduct this, and particularly Dr. Gaurav Kumar Bharti from that is IEEE Bhopal. So he is the one initiated this, and because of him, it is coming into the shape. Because of us, because of him, every one of us are attending this program today. So I wholeheartedly that is thank Dr. Gaurav Kumar Bharti, as well as Dr. Srinivas, IEEE Bangalore section chair, and our Dr. Preeta Saran, because they have involved much in this, and because of these three people only, we are that is joined together for discussing about the advancement in quantum computing and sensor technologies. And also our heads of the departments, particularly from CSE, Dr. Saravana Kumar and Dr. Kanavalli from IFC, Dr. Manju Devi from ECE, as well as Dr. Devi Vigneshwari from EEE. So they have taken effort with short duration, so that 100 plus participants, they made it for this program. I wholeheartedly appreciate and congratulate them for taking a lot of initiative on this and bringing this into some shape. So definitely after 2 weeks, so if I hear the feedback from all of you, I think I'm waiting for that day. So I wish all the organizers this 2 weeks FDP program is going to be a very grand success. And also that is, I would like to thank you all for the opportunity given to me. Thank you.
Thank you, sir. Now I request convener Dr. Preeta Sharan ma'am, Dean R&D, the Oxford College of Engineering, to brief about the FDP session.
Thank you, Visalini, and thank you, Principal Sir, for inaugurating this session. And it is my great pleasure and excitement that I welcome you all who and all are present here, and my special welcome to Professor Ciro, who agreed, although it is very late night there in Peru, South America, but still he is ready to give the keynote address. So thank you, sir, for being with us. And other guest, afternoon guest, Professor Rajmani from Malaysia. She is also there now. She is also present now, and I requested to join us at the time of the inauguration. So she is there. And Dr. Sandeep Kumar Roy from Dubai, he is also present here, who is our speaker for the next day session. So I welcome, and Gaurav sir, how I can forget. So from the outset, I welcome all of you to give us this opportunity, because it was your idea, Gaurav sir, to do 2 weeks. We thought how we will do, but yes, you don't know, just you start. So many speakers were adjusting the time and all, and finally it is coming to one shape now. So now we are very happy, and by seeing the title, when I put in my status, many people are interested for the quantum computing, because they are working on quantum computing. Then I searched and I requested, many speakers are there. Their background is their PhD they have done in quantum computing, and it will be really very, very helpful. Those who are pursuing the PhD in this area, not only that, if they want to start the PhD, they will get a problem definition also, and they will learn what and all they can work in this quantum computing, which is very much required for our Viksit Bharat. And for your kind information, separate budget has been kept from the government of India for the quantum. So our IEEE Bangalore sector chair, Srinivas sir, he was also very happy. And when I shared this title, then his topic is also, he is also giving a talk on the quantum cryptography and QKD, which is very much important to understand for us. And in this way, we will grow, and our skill will be developed in terms of the quantum computing and sensor technology. So these two topics we have chosen, and I hope all the participants will get a lot of benefit out of this. So thank you for giving me the opportunity. So without delay, actually, Visalini, we will tell Professor Ciro to start, because
Yes,
he is
ma'am.
waiting for his time.
Thank you, ma'am. And now I call upon Mr. Jairaj sir, Assistant Professor, Department of ECE, to introduce our chief guest and keynote speaker, Dr. Ciro.
Am I audible, ma'am?
Yes.
Professor Dr. Ciro Rodriguez is a distinguished senior member of IEEE and a full professor at both National University Mayor de San Marcos and the National University Federico Villareal. He is recognized as a qualified researcher by Peruvian organization RENACET and has a portfolio of over 170 publications indexed in databases such as Scopus, Web of Science, and IEEE. Dr. Rodriguez's expertise is frequently sought after as a peer reviewer for high-quality journals like Applied Sciences, Energies, Ambient Intelligence, and Humanized Computing, Multimedia Tools and Applications, Processes, Sustainability, Separations, and Helion. In his illustrious career, Dr. Rodriguez has secured 2 national and 2 international patents, evidencing his innovative contributions to his field. His academic pursuits have led him to advanced studies at Institute of Theoretical Physics, ICTP in Italy, the US Particle Accelerator School, and a specialization in Information Technology Development Policy at Korea Telecom in South Korea. Dr. Rodriguez's research is primarily centered on informatics, artificial intelligence, and big data, focusing on tackling contemporary challenges in health, welfare, environment, and cybersecurity. He is a coordinator and evaluator of national and international research projects. As a thesis advisor, he guides both undergraduate and graduate students. He is also an esteemed author of various books and book chapters. His contributions to the field have been recognized with the Scientific Merit Award in Engineering in 2022 and 2023 at the National University Mayor de San Marcos, highlighting his significant scientific production and participation achievements. As a chair, editor, and speaker, Dr. Rodriguez has a commanding presence at international conferences, further showcasing his leadership in the scientific community. We welcome you, sir, and I request you to take over the session.
Okay, thank you very much for the presentation. It is an honor for me to stay here sharing with you this special moment where you are organizing these 2 weeks of international FDP on advancing in quantum computing and sensor technology. Well, I will give my presentation.
Yeah, you want to share your slide? Yeah, it's coming.
Okay, it's okay?
Yeah, it's okay.
Okay. Well, before I start, I want to thank all organizers, the principal, Dr. Cannon, and Britta Sharon. The Oxford College of Engineering, we have a very hard collaboration since various years, where we are helping to the students to know about quantum technology and photonics, and also sharing with applications, with Android applications for some projects that can help to the students to get a special advantage with the technology. So I'm very happy to stay here. And well, I will start my presentation about smart medical prescription systems using fuzzy logic for various diagnoses. Okay, the name in Spanish is Sistemas de Prescripción y Medicación de Control Sanitario para Ciudadanos Vulnerables en el Perú. Okay, well, this is a paper that was presented in the journal of the university about with all students from Peru, professors also, and also 2 collaborators from India, Dr. Vera Magnikan, MRM, and Dr. Vikas Kular also, that has been participating with the collaboration of this research. I want to start to show you this this map, the global map, where in orange color is Peru and green color is India. Okay. As we see, is we are far away. We are a difference or time difference of 10.5 hours, but it is not a barrier. It's not a problem where we can show and share our knowledge and collaboration. So the objective to present this map, that means that in Peru and in India, we have almost the same problems. The problems in the world are common, are the transportation, the health, okay, the security, are many problems, common problems that we are in many times we are trying to solve, okay. So now I will show you the map of Peru. This is the map of Peru, okay? Peru is a privileged country that have three we have regions, okay? Very marked. We have here three colors, yellow colors that mean the coast, all the coast. The beach is close to the sea, okay? The orange color is the highland, okay? And the green color is the jungle, okay? We have these three regions very delimited, okay? So what is the problem that we have to face in our country? That there are many people that live here, okay, in the highland, okay, like these children's, okay, like these children that are on the farm, okay, working with the so cold temperatures, okay, and we have also the one marvelous of the world like Machu Picchu. All is this in the highland, okay, and so also we have the jungle, okay, where still are Amazonian habitants, okay, that the highland and the Amazonian habitants have the a big problem. The big problem that there is no connection technology in these places. So many of the habitants, people, has no a doctor, okay? And so in these remote spaces, we need to do something to collaborate with people that has no there is no technology and there is no physicians that can help them to solve problems of health. So also there is no medicaments, okay, medicines that can support them. So because they are far away of the city is here in the center, okay? Like many of the cities is centralized all the government, okay? But these zones far away are suffering from the technology and the physicians that can help them to solve the problems. So explain this antecedent, this background about the situation or the problematic situation. So we explain that we can propose, okay, and research on a system that can help to these people that is far away in the highland, okay, and the jungle, that they can have, okay, with a remote application, okay, can be have the information to solve the problems. So this system in Peru seeks to improve access and control to medicines, especially in these remote areas. So it is important to guarantee the safety, the efficacy, and quality of these medicines that can help people to prevent the circulation of counterfeit or expired products. So the system is to cover the prescription by health professionals and dispensing and finance consumption in pharmacies and following national guidelines and regulations. So for build this system, we are taking all the national policies that regulate the prescription and dispensing and consumption of the medicines. One of the issues of the conventional medical diagnosis, it is the imprecision and inaccuracy. So which has been claimed with countless lives. So an expert system is beneficial in the identification of any medical condition and classifying various diseases or illnesses. That is the main purpose of these systems. So an expert system collects information learned from any physician or specialist and keeps it in a knowledge base, okay, that this was created. So when an expert system produces a result from a particular condition or use that matches the result given by a doctor, so the system is considered accurate. So in this proposal of the system, it's essential to developing a system of experts for medical condition and taking the rules of the system that make are closely correlated with the amount of information that it has left. So the levels of clinical decision-making system are based on system based in knowledge and system based in no knowledge. So in system based in no knowledge can use genetic algorithms or neural networks, okay? But system knowledge based in knowledge use rule-based and can use also fuzzy logic and also evidence-based. Okay, so developing intelligent systems is an application of computational intelligence to address these complex challenges. So we know that the classic rule-based approach encodes knowledge using the antecedent and consequent structures, okay? In antecedents and consequence, we have effective features and the consequence and learning achievement. So as new data is received, it is matched against the antecedent clauses of each rule. So rules whose antecedent match the data are fired. So defining the consequence clauses, so no new rule can be fired until the intended action can be achieved. So taking in consideration this information, in recent years, fuzzy logic has emerged as a valuable technique for the intelligent medical systems. So as a subfield of artificial intelligence, fuzzy logic is one of the algorithms, models, and technologies developed to achieve this accuracy. And so as a result of this, the number of patients dying in hospitals on a daily basis has been significantly reduced. And so furthermore, fuzzy logic is an effective tool for decision-making mechanism like expert and pattern classification systems. So several medical experts have already employed this fuzzy set theory. What are the applications of fuzzy logic? The use of fuzzy logic can be applied in environmental control systems and business rule engine, automobiles, medicine, aerospace, natural language processing, dishwasher, chemicals, copy machines. And what are the benefits and challenge of the fuzzy logic? Well, the advantage of the flexibility, the simplicity, the fault tolerance, and the speed and reduced complexity. But the disadvantage are also is the subjectivity, the lack of transparency and difficulty in optimizations, and also the limited applicability and computational complexity. So, for this research, we search in the literature, okay? So we found many information, okay, related to hospital data, publicly available online data sets about the COVID, the hospital data, unit critical, okay, with the heart disease data sets and real and simulated data sets. Many informations that we can take to analyze how the adaptive neural fuzzy algorithms outperform the fuzzy intelligent machines. So there are many medical products of fuzzy logic. For example, Dr. Moon, available managed by Borland Delphi version 4.0, a knowledge base for Borland paradox database, also a knowledge acquisition, VNITLD, by the doctors. And also another product is the patient database with available with the machine record information. What we work in the methodology. In this methodology, we include people that is in remote locations, as explained before. In my country, there are the three regions: the coast, the highland, and the jungle. So we look for in these health departments authorities in various parts of Peru. So it helps to identify barriers to accessing health service. So all vulnerable areas are covered with these smart applications or devices for diagnosis, basic and medical issues without any delay or not being required to wait for a doctor to visit. So we have here, okay, we have the remote system with a database that is communication with this system, okay, that is connected to the cloud. And so the doctor can analyze the information, okay, and record all the information received can be used on mobile, okay, they take the pressure, for example, take all the information, and as the information is sent to the cloud, it all, and after is shared with the physician who will take the best prescription, okay, to solve the problem. So to construct, to build these sensors, okay, we have many components for these prescription systems, like Raspberry Tech, Arduino, as SanDisk Ultra, Wayshare, Logitech Nano Wireless Keyboard, and Arduino Uno Wi-Fi kit, infrared temperature sensors to take the temperature of the patient, okay, blood pressure sensor also to take the blood pressure of the patient in this Highland or Django city. So HD endoscope camera sensor also to take information, data to used to a camera USB, okay, because the doctor or physicians just not take the evidence, okay? They just need to see the patient. That's the one of the reasons, because not all the intelligence systems are very perfect, okay? Because the knowledge of the physician that is prepared during almost 7 or 10 years old working, learning, looking the patient, what is the color of the eyes, what is the color of the skin, what are some symptoms that they can detect, how is the sick that is the patient in this moment is suffering. So it is important to also use a speaker and microphone to hear the voice, what the problem has the patient. For example, maybe the patient cannot express or communicate information. So it's very important to have all information to the physician can find, okay, with the sensors applied, okay, find the really real diagnostic. So the intelligence systems just are like a support for the physician. They are not have the definitively decision of what is really, okay, the situation of a patient. So we have here the components. As these components are used and compounds with interfaces, okay, and connectivity to join and to process all the information, to catch the information and process. So the proposed physiologic model for medical diagnosis, we are proposing the model to deliver optimized output for the medical prescription, such as the modern system in the industry 4.0 is an unavoidable contribution toward the growth of the healthcare system. So the most important part in this is reducing the work pressure to handle a more number of patients in urban areas by employing more physicians with a smart application usage. So in the first phase, about how the physiologic model works with different sets of inference rules. And so the second phase is about smart applications working the model with medical diagnosis system with architecture diagram. So in the architecture, okay, we have input parameters, fusification, rule-based inference engine, and the fusification and output, okay? So in this architecture, the input parameters, we are gathering all the data, okay, including the symptoms, test results, and other relevant information that could be imprecise and vague. And fusification, we are converting CRIPS input into the fuzzy sets to represent the degree of membership, okay, belonging all the elements to a set. And in the rule base is defined the relationships between the input variables or symptoms or output diagnosis, okay, using these rules. So in the inference engine, we are using the logic operations and or not, okay, to evaluate the rules based on this fuzzy input data, okay. So in the fusification, we are convert the fuzzy output from the inference engine, representing a range of possible diagnoses. And in the output, we obtain the specific diagnosis of a set of possible diagnoses and their corresponding probabilities. So this is the architecture. We have here the knowledge base. We have here the input, increased input, that is fusifier. And so this is based in rules. Okay, here is the engine, the inference engine. Here the fusor, and so we have here the crisp output. With all the components that previously we the sensors and all the components, we represent this block diagram of the prescription system, where we have the Raspberry Arduino, and we are sensoring here the temperature, or sensoring here the heart rate. Okay, so we construct a web server for decision making. Okay, taking all the information of these sensors. So we can, with this web server, we can make the decision of what medicine can be dispensed by the system, and what medication, okay, could be used. Okay, so in the implementation results, we are using React to develop the dynamic and interactive user interface in the data collection. Okay, so we develop a website platform for medical diagnosis, and this is basically a component-based approach to working with reusable components like multiple user interface. Okay, we have here the web page where we can, this is the historial of the patient, where we have all the parameters that we are collecting. Okay, and this is will be sent to the physicians to take the decisions. And this web page, we are we incorporated a questionnaire for health diagnosis. For example, we can rate, for example, the level, extremely disagree, extremely agree, okay, with the 1 to 5 and Likert scale. So the first we take information, personal information like name, age, gender, contact number, email address, okay, address, and also have information about the medical history. So are you currently under any medication? If yes, specify, for example. Okay. Do you have any allergies? If yes, specify. If you have ever been hospitalized, do you have any chronic illnesses or medical conditions? And also the lifestyle habits, for example, if you smoke or consuming alcohol, or would you rate your stress levels? How many hours of sleep do you get in the average per night? Are you physically active? Okay, and general health. Okay, the experience of any pain or discomfort on a regular basis, or have you noticed any recent unexplained weight or loss or gain on that? And every information is very important to take for the physician, the doctor, to take the decision about the diagnosis with the information that is collected by the system. So we can also include the parameters of the physiological health, for example, blood pressure, systolic blood pressure, the diastolic blood pressure, heart rate, okay, body temperature in centigrades or Fahrenheit grades. So how is the respiratory rate, breath per minute, and the height measurements in centimeters, okay, weight measurements in kilograms, okay. calculation based on height and weight. Okay, so measurements in centimeters or inches or oxygen saturation, blood glucose. Okay, any information that is included in the web page that is created in React, where we can process the information, that this information will be delivered to the physician and the doctor. In the implementation results, we have taste difference with the diabetes study with physiologic. We are now entering into the processing of the information, okay? For example, fever diagnosis, okay? We have an input temperatures that it can be low, medium, or high, or we have an output a probability that can be absent, possible, or likely. And so we have the rules that if temperature is low, then we can is probability, the fever is probability is can be AB, okay, or is absent, okay, or if possible or likely, okay. We are using this inference with the engine model, okay. So for example, if we can detect diabetes risk assessments, we can also apply the rules, okay, with the familiar story, for example. For example, if they have diabetes risk, okay, it's very important for physicians to know the family story. It's very important to take the decision for the diagnosis. So these all rules are included in a program made in Python. Okay, so when we are processing, okay, the information, okay, that is collected by the sensors, okay, and is entered in the web page elaborated with React. And so we have here, okay, the control system, the simulation of the what is the output, okay, that can be a results, okay, you know, with the conditions of the patient. And so this work was implemented with 4 major parameters studies with heart rate, body temperature, respiratory rate, and oxygen saturation. Okay, here we use the FUSI rules, the reference for analysis of results with the variation of the outcome range. And so with the input FUSI rules, we can have these different, okay, images where we can identify the important parameters with heart rate, for example, if low, poor, or medium average, okay, of if it is high as good or is like with other input range for the oxygen saturation, okay. So we can evaluate this with this. So we can also consider the output FUSI analysis outcomes. Okay, for example, here we have the output results for various input analysis with all parameters and range in low, medium, or high. That gives a good efficacy results outcomes based on the most accurate FUSI rules that we have implemented. So and they have more results of how the FUSI system is identifying, okay, the values. All the implementation results were made in this very poor. We can see here. This is in the jungle. Okay, this is a place known as Belém. Here is the Professor Ulises This is of the research group member. And so here we can see that in these houses are high because in one moment the river cover all of this. Okay, so many people, very poor people, okay, suffering many of the disease that they cannot, they don't have a physician close to help them. So we went to the medical station where we test the system, prescription system, okay, evaluate all the components, okay, how the results. So we have a very good results with the later were evaluated by the physicians, so they could validate these results like a good results with the fuzzy logic. So in conclusion, while we are developing fuzzy logic-based medical diagnosis systems, we can revolutionize disease diagnosis in healthcare. So particularly in diagnosing, okay, complex disease like heart disease and cancer that actually are they are causing very damage in the population, okay? And there is still no result. But if it is detected in the prior stage, it can be alleviated and have a solution. So there are the ability to deal with the medical data uncertainty and the imprecisions can lead to more accurate and quick and efficient diagnosis process. So, however, the full realization of the potential in healthcare hinges on overcoming computational limitations and ensuring their reliability through rigorous validation. So the key components of such systems include input parameters collections and falsification of data. So we need a rule-based developed with an expert knowledge and inference engine and the falsification to provide clear diagnosis. So the medical science continues to evolve. And so fuzzy logic stands as a potent tool, okay, that promising to significantly enhance the efficiency in the medical fields. So despite this advantage, implementing fuzzy logic in medical diagnosis presents challenges. These include the lower computational power than some machine learning models. Okay, this is very common when we are processing more amount of data. Okay, so it's needed to the assumption of derive the results and system developments and validation complexity. So furthermore, we are ensuring that the accuracy of the reliability of this system remains a critical challenge. Well, we have here some reference that we are use it to develop the prescription system. And thank you for your attention.
Thank you, sir. It is an most wonderful session. You have given more insight, informative words about smart medical prescription system. It is more informative and it added value knowledge for all the people who are in the session. And now I request any of the people, if you have doubts, you can ask. You can unmute yourself and you can ask the doubts. Sir is there to answer.
I think doubt will not be there because sir was taking it from the scratch, and we were so much interested to know about the Peru, and he started his talk from the Peru, how people are living and the children how they are facing. So it was like a he started from history. So we were there only. From there he
Yes.
came to the technology level. So this was very
Yes.
wonderful talk. I think this was like a story telling you were talking, and we all were involved so much. So I think technically, I think don't think any this one will be there. So it was very good, very nice talk.
Yes, I think that we can still working with some words photonic your device, okay, lab on chip that we can implement. Okay, so will be very interesting to mix our research and try to help some people that really they need this solution with physicians that there are few in this some the very remote zones in Peru. Maybe in India, but there are also remote zones where there is no technology,
Yes,
where there is no
yes,
physicians. Okay,
yes.
so we have many problems in common that we need to solve.
This is the real time help.
Yes,
Scientific community can help the people and society.
yes.
Thank you. Thank you very much. Thank you.
Thank you.
Okay, Visalini.
Ma'am, now session is over. Afternoon, we will be giving the session.
Yeah, afternoon now from Dr. Rajamani, 2 o'clock from Malaysia.
Okay, ma'am. Thank you, audience. Today, we will be conducting a second session in the afternoon. So we will request you people to join by 2 o'clock by using the same link. On behalf of Oxford Engineering College, I wish you all a very happy learning. Thank you, one and all. Thank you.
Visalini, in between photograph you are taking, na snapshot?
Yes, ma'am. Yes, ma'am. We have taken.
Okay. Thank you.
Thank you.
Thank you, Professor Ciro. Thank you. Thanks to all who joined. So we'll meet by 2 o'clock.
Audience have given comments. Professor, it is very informative session. Thank you, sir, for your wonderful session. So like that, all thankful words are coming from our side for giving valuable information about how to help the rural people. Thank you, sir. Thank you once again. Participants, the afternoon session will begin at 2 p.m. We request all the participants to connect by using the same link at 2 p.m. Thank you. Feedback link will be shared in the afternoon session.